All right, I'm gonna go ahead and get started. All right, so I'm looking at section 1.3, which is integers and fractions, which I should have renamed integers and factors. Okay. So in this class, we're basically gonna be working with numbers. So it's really important that we just kind of understand how numbers work in the most basic way possible. And I'm going to be so I'm going to talk about something which probably is pretty simple to you, but if we mess up how to just add and subtract stuff, it doesn't matter how good you are at other things. So I will, if I'm teaching someone calculus, which is much higher math, or trigonometry or something, one thing that happens a lot of times, even with higher level students who are in higher math classes and stuff, is I'll be trying to teach, like they'll understand all the concepts for how to take a derivative or how to take a sine, cosine, or tangent, and then they'll leave off a sign. So even though stuff like how do I add two numbers together seems like a really simple question that everyone should know the answer to, I'm not going to assume that, because I even have calculus students or trig students who have problems with that. So I'm going to go through it. So when we add numbers together, the basic rule is if you have two negatives, it stays negative. If you have two positives, it stays positive. So a positive is a positive is a positive. If I take a positive plus a negative, it's either negative or positive. So it's not like we can just immediately be able to tell just by saying, okay, we have a positive and negative. Okay, I automatically know which one it is. We have to kind of do a little more investigation to see whether it's negative or positive. If I have negative plus a positive, I can't necessarily say, oh, I know it's negative or I know it's positive. We have to do a little more investigation. All right. So I'm going to relate this instead of thinking about this in terms of simple kind of, instead of thinking this abstractly, let's take this and make this a little more concrete. I like it when things are concrete. I'm going to think about a couple of ideas. And I think I'll actually go to the whiteboard with this one. More space. You should be able to see the whiteboard as well. But I do kind of want to make this a little more concrete. All right. So let's think about this first rule. So the first rule we're going to think about is negative plus negative is a negative. There we go. That's the first rule we want to think about. If I have a negative plus negative, I get a negative. All right. So if this is the first thing I'm thinking about, if I got negative plus a negative is negative. Let's take some real sums and actually like think about it. So this month I had to pay $575 for my rent. So $575. This. Let me stop sharing screen. There we go. So that's how much money I had to pay to be able to stay in my place where I live. $575. Okay. Now, to me, that's a negative. To my landlord, it's a positive, but to me, it's a negative. So I'm gonna call it negative. Negative 575, I'm gonna say. All right. Then, on top of that, I'm gonna say plus. On top of that, I gotta pay utilities, which were especially high this month. Well, higher than normal. So they were somewhere around. Since I'm by myself, I don't have as much in utilities. There's around $90, which is probably a lot. I don't know. It might be a little. But I've had to pay that much, and that all it is. That's rent, utilities. This isn't counting internet. This isn't talking about gas. This isn't talking about car payment, loan payment, car repairs. None of that is included in this. But at the very least, I know rent and utilities. That's what I have right there, just listed out. All right. Now both of these are negative to me because they are expenses. I don't like having to pay this much, having to pay rent, and having to pay utilities. So I'm gonna call that negative because it comes out of my bank account. Now, if I spend money, then spend some more money, at the end of the day, all I'm doing is spending money. Let's round this to something a little bit easier so it can be easier to figure out. So we'll say 600 and we'll round this to 100. Let's go ahead and we'll make even numbers so that we can make it easier to kind of work out without having to go through a calculator. All right. So I have rent of 600 and utilities of about 100. So the question is, how much money did I spend? So what I want you to do is in chat, I want you to tell me how much money did I spend on rent and utilities. So you have a chat function, you have a chat button, you can go ahead and type that number. How much money did I spend in rent and utilities based upon the fact that I have these numbers, 600 and 100. All right. Easy. Now, you see how easy that was. It was super easy to figure that out. Notice I'm not thinking of that as a negative number and a negative number. I'm thinking of it as like, okay, if I spend $600 and I spend $100, how much did I spend? $700. So instead of thinking of math, because oftentimes what we do, don't think of math as these big abstract concepts. What we're going to try to do, what I'm going to try to do is at least is get us to think, okay, negative 600 is me having to spend $600. Negative 100 is me having to spend $100. What does that mean? Because I know what that means because I have to think about it every single day. I have to think about my money every single day. So that is negative plus negative is a positive, is a negative. So if I spend money and spend more money, all I did was spend money. A negative plus a negative gives me a negative. That's how that works. Now I can change it to a positive. And so let's say I make, I don't know, $7 an hour. Let me calculate this out real quick. If I make $7 an hour and I work, let's say 20 hours a week, that's about $140 a week. And for 4 weeks, that's what, $560 a month. 7 hours, 20 hours a week. That means $140 every week times 4 is $760. Okay, yeah. All right. So let's say I get about $560 a month from a job. And let's say unemployment gets me, oh, what was the last thing I was quoted? Like, it was like 200 a week or something. So about 200 a week is about 800. So unemployment. So I've got my job. I've got unemployment. I think it was 200 a week was the last quote I saw. All right. So between my job and between partial unemployment, so maybe somebody, you know, maybe in one household you have unemployment and someone has a job, something like that. I've taken about 560 and taken about 800 between my job and unemployment. All right. So between my job and unemployment, I make how much? Well, it's a simple arithmetic. I'll make it a little simpler, down to 600. So 600, 800 is 1,400. And I'm gonna put a plus here, positive 1,400. And you can see how that works. If I'm making money, I'm making 600 and I'm getting 800 in unemployment, or somebody in my household is, I don't know. Maybe I'm the one, maybe someone else is getting unemployment. But if one of us is getting 600, the other one is getting 800, all together, we're getting 1,400 per month, which may or may not be a lot depending on how many people you have in your household, what your situation is with medical bills and stuff. So a positive plus a positive makes a positive. And again, that makes perfect sense if we just think about how that would work. Positive with positive makes a positive. If I'm bringing in money and bringing in more money, all I did was bring in money. So I can see how that works. All right. Also notice them adding these together. I'm taking 600 plus 800 to make me 1,400. But what's interesting is I did the same thing when I did the exact same thing when I subtracted. So notice that when I had negative 600 plus negative 100, so I had negative 600 plus negative 100, I still added 600 plus 100 gives me 700. So I still added, even though these were minuses, these were negative numbers. All right. So this brings us to our basic rule about when we add, when we have the same sign. When we have the same sign, we add. Think of it as going in the same direction. If all I'm doing is spending money, going into the negative, I stay in the negative. And it just keeps going in the same direction. All right? So negative 100 and negative 200 gives me negative 300. If I have positive 100 and positive 200, it gives me positive 300. All right, cool. So that's pretty simple. Same sign, add. All right, so that's going to be a rule for same signs. Now let's take a different one. All right. Now what if I have a P plus an N, a positive plus a negative? So let's think about situations. So let's say I bring in that 1400 I was talking about. And let's say my main expenses wind up being that 700 I was talking about. So I brought in 1400 between my job and unemployment. I spent 700 on rent and utilities. And if it was more accurate, I would have to account for gas, which is somewhere around 80 bucks. Then I would have to account for my internet, which is somewhere around 40 bucks. Then I would have to account for having to pay on my loan, which is give them somewhere around 80 bucks. Then I have to account for food. So we'll cap it at 80, which is ridiculous. Let's go ahead and just say 100. And we'll stop there. Even though there's more stuff, we'll stop right there. I think I've done most of it. Water, heat, electricity, internet, car payment, or loan payment, rent. Okay, I think I've counted for most of it. All right, so now I'm going to ask the question. Based upon this situation right here, so if you look at this situation, I brought in $1,400 from job and unemployment. Between me and another person in my household, we brought in $1,400. I had to spend $1,000 on all the different things I have to spend it on, like rent and utilities and blah, 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 right? All the stuff that you have to spend money on. The end result is going to wind up being, is the end result going to wind up being positive? Or is it going to wind up being negative? So is it going to be POS or NEG? Go ahead and tell me in the chat. So I brought in $1,400, but I spent $1,000 because I had to spend it on rent and utilities and loan payment and groceries and, well, I didn't even count for gas. Gas is in there too. Let's put gas in there. We'll put about what, 100. Let's put some more expenses in there. We'll go up to 1,100. There's more expenses. I'm not even accounting for everything, but All right. Positive. Now, everybody. Can anybody tell me why the net result is positive and not negative? I think I've got everyone muted. Positive or bigger. All right. Put that in simpler terms. Instead of thinking about it just mathematically, what's in simpler terms, based upon this example, what makes the positive number bigger? All right, what are we doing here? Okay, that's good. 1400 is bigger, but let's even simpler. I'm talking about you're trying to describe this to somebody who has no idea how positive and negative and numbers and blah 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 works. What's the simplest way of saying why this is positive? I'm trying to get past the math here. I'm trying to get down to the what is going on. Okay, so someone in the chat said you still have money left over. So I realize that I'm kind of pushing it, but I really want you to tell me. All right, I think we might just leave it there then. All right, let me say it the way that I want to hear it in my head. You made more money than you spent. So you made more money than you spent. How much money do you have left over? $300. All right, so you have $300 left over. But in this case, what we're having to do is subtract. So 1400 minus 1100 gives us 300. So the rule for different signs is different sign subtract. So these signs are different. We're going to subtract them. Now, I'm not going to go through the negative plus positive example just because it's pretty simple. All right. Oh. Share my screen. Now you're probably thinking, I spent way too much time talking about adding, subtracting numbers. And that might be true. But I've seen enough mistakes that I'm just going to go ahead and spend a lot of time on it. All right, subtracting real numbers. When we subtract real numbers, basically what we do is we use what's called keep, change, flip. Keep, change, flip is basically just we take the first number, we keep it the same. So in this case, 5 stays a 5. All right, the minus gets flipped or changed, or sorry, gets changed into a plus. We keep, we change a minus to a plus, subtracting to adding, and we flip. So the 2, notice the 2 is a positive 2. There's no sign in front of it that makes it negative. This is a minus, this is a, so we distinguish between minus and negative. So we have a 2. The 2, the positive 2, gets flipped into a negative 2. All right, and then we just use the rules. And the rule says if it's different signs, subtract. So we get a 3, take the bigger sign. It's a positive 3 because 5 is bigger. All right. Multiplying numbers is actually even simpler. Multiplying numbers is basically just if 2 numbers have the same sign, they multiply, get a positive number. If 2 numbers have different signs, they multiply, get a negative number. So it's actually really simple. The main thing that I want you to take away from this is when you're adding numbers together, it's different than multiplying numbers. And that's a really important concept in mathematics, is adding stuff and multiplying stuff can be really, really different. And you kind of have to keep that. So you have to kind of create a partition, like a wall. And on one side you have, this is how we add stuff. On this side you have, this is how we add stuff. On this side you have, this is how we multiply stuff. And you have to, in your brain, go, okay, this is adding, that's multiplying, they're different, they don't mix, they aren't remotely similar. And you just have to kind of establish that in your brain. And just say that. All right, this is how we add numbers, this is how we multiply them. They're different, we keep them separate. Okay. All right, so those are just the rules. You did a practice on that. You probably got all the answers right on it. All right, dividing real numbers. Dividing is basically similar. It has the same rules as multiplying. So those are multiplying rules. And division rules are the same. So if you can multiply, you can add. All right, or divide. Except there's one really, 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 really important rule in math. It is really, 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 really important. And it's one of the most important rules in all of math. There are only a few things you just can't do in math. You can do a lot of stuff in math, but one of the things you cannot do under any circumstances is you cannot divide by 0. You just can't. You can't divide by 0 under any circumstances. So let me explain what I mean. Here's what I don't mean. Or, so I'll say what I do mean and what I don't mean. First of all, you cannot have a 0 in the bottom of a fraction. If you have 0 at the bottom of a fraction, that's bad. You can't do it. It's impossible. If you try to put that in your calculator, 1 divided by 0, it doesn't work. So, and your calculator won't do it. I don't even think your phone will do it. Let me see your phone will do it. Haha. My phone won't do it either. When I put 1 divided by 0 in my phone, it says can't divide by 0. So literally, if you use your phone, your calculator, and you try to put something in and divide by 0, it will tell you can't do it. If you put it in a TI-83 or TI-84, it'll say error. It will tell you that you can't divide by 0. So your calculator will tell you you can't divide by 0. You cannot have 0 on the bottom of a fraction. However, you can have it on the top of a fraction. So you can actually have it where 0 divided by 1 goes into your calculator and you get 0. So that's fine. You cannot have 1 divided by 0. Your calculator will tell you, if you type into Google, whatever, it'll tell you. I have this little kind of illustration here that I think is really helpful, is that if you have 0 on the bottom, you can't do it. That's a no. You have 0 on the top, that's okay. So that's the main thing. Again, I'm going over a lot of simple stuff you've probably already seen before. You probably know all this stuff already, but I'm going over it because it's really important that you get it. All right. Cool. Now, let's actually get into some math stuff. The question is, what is a factor and what is a prime number? And to do this, I'm gonna look at this first, then I'm gonna exit from here and yeah. All right. A factor is a number that goes into another number. So I'm reading it straight from the screen, but again, I just typed it all out so you can see it. So it goes into means it's smaller than it, are of the same size. So 2 goes into 8. 4 goes into 20. Which is essentially the same as saying 4 is a factor of 20. That's what we mean by factor. Some factors of 20 are 1, 2, 4, 5, 10, and 20. These numbers all go into 20. A number like 3 does not go into 20, because if you say 20 divided by 3, you get a decimal. So we don't like that as much. When we say factors, we mean they go into it evenly. That's what we mean. Some factors of 45. 1, 3, 5, 9, 15, and 45. These are factors of 45. These go into 45. All right. Now we do definition. Second definition, prime number. A prime number is defined as a number that has only 2 factors. Only 2 numbers go into it. Nothing else. 1 and itself. So if I have a 2, a 3, 5, 7, 11, 13, so on and so forth, if I want to break those down into smaller numbers with multiplication, by dividing them into smaller parts, basically, I can't really do it because 2, the only thing that goes into 2 is basically 2 and 1. The only thing that goes into 3 is 1 and 3. That's it. If I had a number like 8, for example, let's say 8. 8 could be broken down to 1, 2, 4, and 8. There's a whole bunch of different options. But if I have something like 7, 7 doesn't break down into a lot of different options. It's 1 and 7. That's it. That's all you can do for prime numbers. It's only so far that you can break it down into a simple number using division. All right. So that's a basic definition of a prime number. So why would I want to find the factors of a number? Find the factors of a number that are prime. So why would I want to do that? So go back, we said factors and primes. Why would I want to find the prime factors? The reason why I want to find the prime factors is because, let's say I have a really huge number like 1,260, and I want to take that number and do something with it. 1,260 is a really big number. I don't want to do stuff with 1,260. The number's too big. Even I don't want to deal with a number like that, and I do this for a living. So I don't want to deal with 1,260. But I can actually take 1,260 and break it into smaller parts. And that'll make it easier to deal with in the long run. Let me show you some common mistakes in it, though. And to do that, yes. But one common mistake that we see in prime factorization, when we do factor trees, is students will have the tendency to say, okay, I'm going to split 280 into two parts. So that means 280 must be 140 and 140, right? Because if I take 140 plus 140, I get 280, right? That makes perfect sense. Totally logical, completely logical and great and smart. It's wrong. That is actually completely incorrect. When we do what's called a prime factorization, a factor tree, what we do is we split them by dividing them. We're dividing numbers, or we're multiplying numbers together to get things, not adding them. So on the left, you see 280 get split into 140 and 140. That's wrong. That's absolutely fundamentally incorrect. On the right, you see we have 280 get split into 2 and 140. That's correct. Because 2 times 140 gives me 280. The correct way of doing it is to think about it as multiplication or division, depending on if you're thinking from these two numbers multiply to give me that number, or this number divides into those two numbers. Just kind of use the logic that makes sense to you. Make sure that you split it using division or multiplication, depending on which angle you look at it from. So, a really common mistake that students make, and I've seen this 100 billion times, is they will say, I'm going to split the number 6. Okay, how are you going to split the number 6? I'm going to split it into 3 and 3. That is not correct. When you do a prime factorization, a factor tree, you split 6 into 3 and 2, not 3 and 3. Because again, we're dividing these numbers, we're not adding or subtracting them. All right. So I'm going to go through an example and basically just explain that. All right. I'll leave that up. And I can just explain that. Cool. I'm going to walk through an example of one problem. And I'll have to make the number up off the top of my head. We're going to do what's called a factor tree for 144. So the number here is 144. We're going to do a factor tree. So the way we're going to do it is we're basically going to try and see, are the numbers, is there any way that I can split 144 into two parts by dividing it, essentially? So we're going to use a very complex method for doing this. It will involve your calculator, whether that's on your phone or whether that's on a TI-80 thing. And it's very complicated. You go 144 divided by 1, 144 divided by 2, that works, is 72. Again, super complicated. So you have 2 and 72. Notice what I'm doing here is I'm spacing it out a little bit. If I put it too close together, if you look at that, it looks a whole lot like, let me make my print bigger. Put it too close together, that looks a whole lot like 272. And you might say, well, I know what I know what I mean by that. You do right now. In about a couple of minutes, you're going to forget what you were doing. Because when you get long math problems, you tend to start to forget. You tend to get involved in another thing. It's kind of like when you're just doing chores around the house and you just kind of forget about that one thing you're supposed to do 5 minutes ago, that you left something in the oven, but you started cleaning, so then you kind of forgot about that other thing. Well, it happens in mathematics too. You basically start working on something and you forget about the other thing. All right, so I'm going to take this and actually I'm going to split it into 2 and 72, and I'll keep them separated out so I don't wind up kind of going back and forgetting that this is a 2, that's a 72. It's very easy to tell because you see how I split it into into like a wide enough space between it. Then what I'm going to do is I have a list of primes, and the list of primes are actually in those slides. You don't have to memorize them. I have a list of primes, and the list of primes is going to tell me what are prime numbers. So if I go back to my list of primes, one of my list of primes is 2. So 2 is a prime. Is 72 a prime number? Well, let's see. Here we go. So I'm gonna look and see is 72 a prime number? Blah, 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 70, 71, 72. Nope, it's not a prime number. That means I can keep splitting it. So I'm gonna keep splitting it. All All right, 72 is an even number. What goes into every even number? 2. And so I'll take 72 divided by 2, goes my calculator, gives me 36. All right, is 2 a prime number? Yep. All right, 36. All right, 36 is a prime number. What does I say? 34, 33, 45, 36. Nope. All right, what can I split it into? So I go 36 divided by 1. 36 divided by 2. Yep, 2 and 18. All right, so I move to that, and I get 2. Okay. 18, is that a prime number? Nope. That's 6 and 3. Okay. Yeah, are either of those prime numbers? Let me see. 3 is a prime number. Is 6 a prime number? No, 6 is not a prime number. All right. So 6 is a prime number. So I'm going to split 6 into what? Well, remember, the main mistake we make is 3 and 3. But we're not going to make that mistake because we know that it's actually 3 and 2. Now, are 3 and 2 prime numbers? Yes, they are. So, if I was to write this out, I think you can know that. Here we go. I have a 2 here, a 2 there, a 2 here, a 3 down here, a 2 right there, and a 3 right there. I think you can see all that. See, yeah, 3 right here, a 2 right here, a 3 right there. So if I was to write 144, I write it as 2 times 2 times 2 times 3 times 3 times 3. And I will stop sharing so you can see it a little bit better. And erase. All right. But I want you to kind of see the flow of it. I took a number, I split it into 2 parts. To that number, I split it into 2 parts. If any of the parts were prime, I circled them. So I automatically circle the numbers that are prime. Just circle them. I didn't circle 72 because 72 isn't prime. But 2 is a prime number, so I circled it. 36 is not a prime number. I don't circle it. But 36 can be split into 2 and 18. 2 times 18 gives me 36. I circled it. 18 is not a prime number. I don't circle it. 6 and 3. 3 is a prime number. I circle it. 3 is a prime number. I circle it. 6 is not a prime number. I don't circle it. 3 and 2 are both prime numbers. I circle it. So my final answer is 144 equals 2.2.2.3.2.3. It doesn't matter that the numbers aren't in order. Not right now, really. And that's it. Now, I want you to notice what I didn't write. All right? I could have written this. I didn't write it. I didn't write it this way. What I could have written is 2x2, x2, x3, x2, x3. I could have written that. And you would probably recognize that. You probably know what that is. Your computer doesn't like it. If you type that into the computer, your computer won't like that. And there are several reasons why, and we'll talk more about it when we start getting into letters. When we start getting into letter part of algebra. But right now, we're just in the number part of algebra. We're not in the letter part. But we're going to talk but when we get to the letter part of algebra, we're going to talk about this X stuff. So that's going to be on the agenda later. All right. I apologize, guys. I don't know why I can't just share the screen really easily. So I'm having to do a lot of like finagling to figure out how to get it to do what I want to do. All right. That's an example of 72. I can do that one. That's 168. That's 1,260. I'm going to that's what we're going to do. So I'm about to take roll for the class. Here's how I'm gonna take roll for the class. What you're gonna do is you're gonna work yes. So here's how I'm gonna take roll for the class. I'm gonna go through the participants, and I'm gonna send you one of these numbers: 64, 350, or 630. What you're gonna do is send me back what the prime factorization is of that number. That's how I'm gonna take roll. So I'm gonna go into the chat. I'm gonna type a number to you. Then what you're gonna do is you're gonna send me back the prime factorization of that number. So you're gonna go through, work out all the stuff. Blah, 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 like so. And you're gonna send me back what the prime factorization of that number is. When you reply back to me, I will count you on the roster. If you don't reply back to me, I'm not gonna count you on the roster. So I'm gonna go to the chat and I'm gonna send you prime factorization of that number. I'm gonna send you a number and you're gonna send it back a prime factorization. We can work it out real quick. And then you're gonna send it back to me. Once you send it back to me an answer or a question or something, then I'll count you on the roster. If you don't send it back to me, I'm not gonna count you on the roster. So I'm gonna start doing that now. You should have some kind of something to write on. Shouldn't take too long. I'll go ahead and get you counted. I'm gonna stop share. I'm gonna go to chat. I'm gonna go down each of these. I'm gonna send you a number, and you're gonna send back an answer. You can use X's as X as multiplication sign. And that's it. If a loss has a goose, let me know. We can unmute and we can ask some questions and figure some stuff out. But once I get an answer back from you, I'll count you. Hopefully everyone understands that. If you're not sure, you can always send me back a private answer. Two times two.
Where is the answer?
The answer to what?
Or the what? Not the answer. Where's the question? Like, where are we supposed to get the question from?
You should have got a message with a number on it. Cool. Exit from there. Exit. I'm not sharing screen anymore. I am going to go to a Word document.
Is it on Canvas?
No, I should have. You should have gotten a number in the chat. Single number.
Oh, okay. Never mind. I got it. Never mind.
Single number in the chat.
Do we send the answer privately or can we put it in the group chat?
Depends on how confident you are. But you can send it privately. It's probably easier to send it privately.
Okay.
All right, good. I'm gonna set up some homework for this to kind of let you guys go over the stuff, learn it, so on and so forth. Just send me the final answer. Don't send me intermediate steps. I need the final answer. You can use X's as multiplication. We're gonna talk about that in a later meeting. That's a whole deal. All right, who do I got? Let me see. Let me go through here and do this business. Jalen. Hey, Jalen's here. Yay. Oops. Okay. One. Leslie. Good. Cameron. I love it. Nathan Winger. Yes. Ruth. Love it. Okay. What else we got? Lakeisha. Indeed. All right, I'm still waiting on. Okay, no. No. And no. I got any responses back from there. That may be everyone. Is that everyone? No.
So, that's not mine.
Okay, that's fine. Does everyone know how to use the chat function in here? Just want to make sure. Chat function is the primary way that I can communicate with you. You don't know how to use the chat function. Let me. Yes, Lakeisha, yeah, I got yours. I got yours. That should be it. They're not here. I'm not sure why they're not here. Oh, I'll give. Yay, okay. And I'm missing just one. So yeah, I know I spent today I spent a lot of time on really simple stuff, you know, and I'll be honest with you, it's like not my favorite thing to talk about, but I'd just rather be safe than sorry. I don't want anyone to get left behind, anyone to like feel like, oh, I'm just rushing ahead and oh, he's just assuming that I know how to do the stuff or whatever the heck else. I'm not assuming anyone knows how to do anything. Eventually I'll get back to first test and I'll figure out everyone knows how to do stuff already and then whatever.
When's our first test?
I have not figured that out yet. It'll probably be next week.
All right. Is there any homework like besides 1.3 open yet?
I'll open up an assignment, yes.
Okay.
It's not open right now. All right, that's all I got.
Wait, so we have homework? We have homework?
You will have homework on this, yes, to practice all this stuff.
So this is the only assignment we have. We haven't had any other ones, right?
No, you still have that preliminary assignment where you just kind of go through and show me what you know.
Where do I find that? Because I haven't did that.
Okay, I think it's called Beginning Algebra Review or something. I don't know what I called it. Has everyone else seen the assignment? I don't know. I don't remember what I called it.
Is it in Canvas?
It's in Canvas. It's in MyLab Plus.
Okay, I'll find it.
Okay. Has anybody had any problems getting on MyLab Plus not loading or something?
I do.
Okay. That's what kind of phone? Do you have an iPhone or like a?
I have an iPhone.
Okay. I would check all the settings. Make sure that you don't have any issue with pop-ups. I don't really know how to solve all those issues, but I would just Google it basically,
Okay.
whatever. The best thing, or if someone else in the chat has had that problem and fixed it, you can send her a message and say, hey, this is how I fixed that problem. Yeah. All right, so I think that's gonna be it. Yeah, that was pretty, yeah. Cool. Let me save this as.
Awesome.
What's today? August the
19th.
Cool. All right. That's it. That's what we have for today. I'm going to go ahead and end the meeting. I'm going to assign some homework. I'm going to send an email giving you guys some information, and that's it. Cool. End meeting. And stop recording.